Welcome, my name's Kevin O'Grady from Arup, Ahmed Sagara from CostOS, and Alex Small from Tata Steel. We're going to discuss how data flow in construction can enable the circular economy. To give some context around 7D, on the map there they've got 3 to 7D, 3D being the digital drawing where the information is embedded. 4D is the schedule information, so from the model we can get schedule information, we can embed schedule information. We can embed cost information, that's the 5D. 6D is sustainability, which is carbon footprinting and looking at areas of life cycle costing. And 7D, which is primarily the focus of our group, is looking at the performance. And from Tata Steel's perspective, Alex, maybe you want to say how that would affect the role of manufacturers.
If you look at how BIM has been integrated into, particularly in the UK actually, people have tended to focus more at the system level than the component level, and that's caused quite a few issues in terms of, if you look at a wall, how do you get all the product data for a wall when there could be 500 different ways that that wall could be constructed from different components. And so starting at that level and trying to go forward, people have hit a bit of a roadblock. So
the word componentisation is now being widely used, and of course components come from construction product manufacturers. So I think there's a lot of us now that have realised that we can play a really big role in digitising construction by getting control of our data, having our own databases, linking back to that single source of the truth, and providing the journey of the product together with the data through the supply chain, through Intersite and into installation and beyond. And yeah, it's an exciting journey.
And to put some context around this session, we're going to discuss a partnership that's come together with leading firms and professional bodies to form the Construction Smart Contract Committee. As part of this committee, we're looking at the data flow opportunities maximising around a smart project, and a proof of concept that will look at the use of distributed ledger technology. So Ahmed Sagari is the chair of our group. Maybe Ahmed, you'd like to introduce yourself and tell us about the group.
Yeah, so Ahmed Sagari, I chair the group. We've got about 130 members now that have gone through workshops and given their view on the whole topic area. We started this back in June 2017. We had a big workshop with infrastructure customers and people, and we asked them the simple question: do you think that blockchain and smart contracts is a worthwhile area to investigate for the construction sector? So we discussed what blockchain was, and then from all of that discussion that we had, there was a unanimous agreement that we should carry on, at least investigate, for a period of time. And we define that period of time as being 2 years, made up of the first year of just having workshops and just discussing all the issues that needed to be addressed and how they could be addressed and whether or not it's relevant to use blockchain or not. Because you can't say this is a one-size-fits-all and it's going to solve everything. We were just going to focus on the things that we thought it could solve, problems it could solve. And we've done that first year, and we've come out that first year. And the next question was, is it worth moving to pilot stage? And so that's where we are now. There's unanimous agreement among all the group that we should now go into a piloting phase. And where we are right now is we're looking at 1 or 2 areas to pilot. Bearing in mind we can't do everything, so we're just focusing on 1 or 2 things that we think are achievable to do. So that's where we are now.
So the pilot itself looks at the journey on a construction site of an airport for a steel beam. And maybe Ahmed, you want to go through some bits about the journey of this steel beam and why it interfaces with so many parts along the journey from specification.
Yeah, so there are 3 basic areas of resource that we need to, in the construction industry, that we look at. There's materials, there's people resources, and then there's equipment. There's lots of other things, but those are the 3 primary building blocks. So we really want to cover every single one, but we can't do everything. So we said, let's focus on one thing that we can achieve, and that we've got people around the table that can help influence the pilots. So we decided on the tracking of material.
So we're going to start at the point where we know what we want. We're going to issue a purchase order to buy that steel beam. So that's where we're going to start. And the purchase order is going to go through one of our partners. It's going to go through a SAP system, SAP, because they their products are used extensively around the world to generate purchase orders and then track payments. So they're going to use their tools to generate a purchase order through one of their blockchain tools, and that's then going to be issued to the manufacturer, where it then goes through the manufacturing process, and then we pick it up again once it leaves site. We keep track of that steel beam to a site, so we're going to have some contractors that are going to be involved in registering that that piece of steel has arrived to a building site.
So that's an element of the blockchain and smart contract aspect. You issue a request to produce something, we track it until its delivery, and then we take acceptance. That is a smart contract. The acceptance is a smart contract. And there'll be a multi-signature approach to that, which is multiple people have to be involved in accepting that steel beam. And then hopefully what will happen out of that is you'll have the execution of a payment term. So it could be that we pay all of them for all the materials, or we pay for part of the materials, depending on how the contract's constructed. And then we go into the manufacturing, the installation process, and that then itself will lead on to a payment contract, which is somebody gets paid to then take it from delivery into construction, put it into where it's supposed to be, and that itself will have an acceptance contract. Yeah. Where we say, yeah, we agree it's been put into the right place, we accept it's been built correctly according to the 3D model, now the contractor or the subcontractor is due a payment. Yeah. And that for us is a really big win for the construction industry, because we can say, once everything's been accepted, the contractor and the subcontractor has to be paid. There's no waiting for 6 months or holding on to money, making excuses. If you agree everything's been done, then that's
I suppose with blockchain it gives you the transparency, trust and security as well around those payments.
Yeah, so you get visibility. Now that visibility can be commercially sensitive, so some people will push back against all of the information being open. So what we're going to be looking at is which bits of the information shall we make open and which we won't. There's an element that's emerging that we can make the confidential information eventually make it open after a period of time where it's not commercially sensitive anymore. After 5 years, who really cares? Yeah. So we'll make some things open.
Things like what material went into the building, who was the manufacturer, who was the installer, what were some of the specification parameters around that, and then the installation costs and stuff like those commercial bits can be made available later on.
Yeah. I suppose from a manufacturer's point of view, the specification at the very beginning, if it's asking for all the Internet of Things and it's asking for a digital project, asking manufacturers for the data, how do you see that benefiting the circular economy if we ask for that data, for example, on the steel beam? If we request from a steel manufacturer data, how does that inform the circular economy? How does that steel at the end of its life have the benefit?
Well, I think it will vary actually product by product. I mean, if you take, for example, a cladding panel for us, if we put sensors into a cladding panel to see how is that performing after 30 years, we guarantee these products for 30, 40 years. So how is that performing at the end of life? We can then couple that along with all of the linked databases through to the production, right the way back to cast number, chemical composition, what was the carbon content of the steel that then went into that. If you couple all of that, what we call the birth certificate data, together with the impacts and everything that happened in the transport to site, together with its in-use performance, together with how was that maintained during its life, and you couple all of that together into a product passport is the term that's being used at the end of life, then you really have usable data that you can start to benefit the supply chain and benefit designers. I mean, significantly more likely, I think, to reuse a construction product if you know all of the information about it, particularly how is it actually performing after 30 years of life? Is it at 95%, 90%, 98% of its original designed capability? In which case you can then gather all that information, and then as a designer you can design a building based on the products that are going to be coming available on the market, rather than going to a big shed full of construction products and trying to find something that meets kind of what you're looking for.
Reusing the products,
reusing that data, I think that really will help to drive reuse. If you can design buildings based on what's coming available because you have all of that information available, I think we could be onto a winner.
So I suppose the cost to a project to write a clause that asks for data. There is no real cost to a project for us for a smart project, so he's just requesting data that the manufacturer already has. But during the life cycle of the steel on a project, if you monitor its deflection, you have a service record now at the end of its life. And is there any evidence that a steel where you know its composition to a steel where you are unsure of its composition, is there a difference in value that the client would have at the end of maybe 60 years?
Yeah, I think so. I mean, if you take a steel beam, for example, if you know that over its design life from the monitoring stress strain on it, you know that it only achieved maximum 40% of its optimal tensile strain, for example, then you know that that hasn't been strained. That's still got its, it's still going to perform at its maximum potential. So the residual value of that isn't, oh well, let's go and chuck it back in an electric arc furnace and recycle it. That's as good as a new product coming out. So the value of that is going to be considerably higher. And I think that's a really interesting reuse driver again for if you look at developers looking at building commercial warehouses, for example, if they know that at the end of 30 years or 40 years of design life, they haven't got a depreciation curve like that because of the residual value of the products. They can sell them at pretty much some of these at prime. They're far more likely to look after them, far more likely to keep all that data flowing through the process and benefit from the value of goods at the end of it.
This is one of the things I like about so building information modelling. When it first came out, so the 3Ds and digital modelling, it came about because the government back here about 10 years ago, when it was looking to try and save efficiencies across all spend and across all departments, it hit a roadblock because when it came to what it owned in terms of construction assets, it didn't know what it owned. So if you don't have intelligence, you don't have market information about what you own, you can't do anything. So what they did was they started a program of trying to increase the amount of digital input into the construction sector so they can have a lasting record. So therefore that starts you off. Once you start knowing what you own and where you own it, you can start making intelligent choices about things like maintenance and also where assets are, when they're due to be decommissioned. So blockchain itself, when you look at the kind of the solution of what it's trying to achieve, it was trying to create a shared ledger that everybody has access to the information at the same time, so that you couldn't steal information or create information.
Or change history.
Record. So you have this thing that happened because the government wanted to introduce technology because it wanted to know what it owned, and also reduce cost because the construction industry has a very, very poor productivity record.
So there are lots of reasons why it made sense to actually introduce technology into that. But then you have this new technology, which itself is 10 years old now, today, that's come in. And we're trying to pull the two together so that you can use the blockchain and distributed ledger to have a lasting record of information about assets, digital assets. And what that then means is that you can start mining the data to achieve what the government wanted to achieve, but you could do it across anybody that wanted to use public ledgers. You could start mining the data for information about what went where, and I quite like the concepts of you're creating a treasure map for the future. As finite resources start getting used, and you can no longer mine them in the ground, you can start mining the data to find out where they are.
Where there's another building.
Where there's another building, it's got specific types of equipment, and you can say, how old is that? Is it worth mining the information to create a factory that targets specific types of resources, and then we'll look at which built assets are probably going to be ones that we want to sort of decommission sooner than others, because the resources that have gone into them we can make use of again, and the value of those go up, and it becomes economical to target specific types of buildings and specific types of factories that are old and things like that.
So instead of looking at systems, again, if you actually come back and look at components, you can use EPD data from manufacturers. Now there's a bit of work to be done to ensure that everybody's reporting the same impacts in the same scenarios and assumptions and things. But once you've got that, the ability for manufacturers to say, well actually, for us as a steel manufacturer, instead of us saying, well, we have to use the industry average module D for steel, which is roughly 5% likelihood of reuse, 5% likelihood that it's going to go in landfill, and 90% likelihood it will be recycled. Actually, if someone's taking your componentization or let's call it construction platform as an example earlier, if somebody has used a steel system that's designed from standardised components that can be adapted, so you have flexible, adaptable buildings, and demountable products because they want to drive that building for maximisation of reuse.
And to use a Module D from a steel manufacturer with only 5% reuse likelihood is crazy.
You won't get the credit, but if you can increase people's chances of getting more credits for it, more adoption would look at re-lifing.
Exactly. When you start to think about, well, what are the opportunities of linking back into a manufacturer's database? Us having 2, 3, 4 different Module D values, depending on how you've designed the building, is the data available, are you focusing on, are you using this system or that system, means you can pull from a different set of data. Have you glued or screwed in your insulation to your plasterboard, your example earlier? You know, so you can get these different values and you can get the value and the credits up front, and you can drive contractors to make those decisions on how they want to build the building. You know, and I think another example of how you can use the data is we're intending to mark with a physical mark or a QR code, something like that, every single component that we manufacture and link it to a 3D component, BIM components ID. Okay. So we can then basically link physical to digital.
Physical one on the beam, or would you say inside the model, the 3D model is a
inside the model, whether it's a steel element or a cladding panel, whatever it might be, we would link that component ID to a physical product, make the connection, link them through, and we then at the end of life. So not only do we get all of the information through that product life on performance, etc., but when it goes into reuse and then it comes eventually back into recycling, you know, we will know all the information about that product, which makes it potentially far more valuable to us, because at the moment we have a process where with basic oxygen steelmaking where we can only recycle up to 20%. You know, so there's raw material, obviously iron ore, coking coal, etc., and only 20% maximum is recycled scrap. When we move to a new technology we have called Hisana, we'll be able to recycle up to 50%.
Well, that's fantastic circular economy, doesn't it? It answers perfectly,
Absolutely. So we'll be going into the market for more scrap. So we'll need more scrap to be available. But because of the difference in the two production routes, electric arc furnace and basic oxygen steelmaking, you can get what's called tramp elements coming into scrap from breaking cars, the copper cabling, etc. Now, as we make from a basic oxygen steelmaking process, we make much higher quality grades that therefore can't have the risk of those tramp elements. It's quite difficult and costly for us to select the right steel products from the scrap market that we know are clean steel products that haven't got those tramp elements. So if we're stamping every single product that comes through, and we know right the way back to our production process that has this carbon equivalent value, it has this copper level, this carbon level, then we know all that information. You quick scan of that, we know whether it needs to go to EAF or basic oxygen steelmaking. So we can make that scrap market significantly more valuable.
Within the pilot then, Ahmed, you're looking at showing the difference between a traditional project where we don't track the data at the moment. In a standard construction site today, where we build a load of assets and stuff, we don't track where the products come from to that degree. If you map the two, and you could show to clients and to governments, this is the delta saving that you will have at the end of life, or as a resale of the building onto a new tenant, this is the difference. Surely that circular economy part is the bit that we're trying to, as a net result from the pilot, is what we're trying to show the clients.
So there is different elements of being able to make use of the data.
There's the immediate use of the data, which is just a track. And then there's an element which is not quite as immediate, but it helps the next project. So if you design a building and you start planning your resources, that's the 4D bit, the scheduling bit. We're going to have this person turn up, this piece of equipment turn up, this material turn up, and then they're going to be constructed in this sequence. Those are educated guesses to a large extent. You may have done a project in the past that's similar, so your educated guess is better.
You're right, so now you're measuring that.
But now you're actually physically measuring this piece of equipment turned up on site at this particular time. The people turned up this time, so you can actually narrow it down to the minute and second that your schedule was due to say these things. Did it actually happen like
And do
that?
scenario bases. Could it be quicker?
Yeah.
Could it be more efficient?
Absolutely. So now the person who's scheduling and who's planning a project, the next project,
It's got real data.
you've got real data that you can get access. And now you can say, we made these assumptions and this is actually what happened on site.
So there's going to be lots of areas where the data is going to have value to the people who generated it and also other people who may be doing something similar. So we're going to be measuring various different aspects of the benefits. For me, the longer term benefit is where building information modelling really kind of wanted to be, which is when you construct something, a built asset, there's a lot of work that's gone in to say, on average, about 10% or 15% of the cost is in the construction. The rest of the cost, the 90%, is in the maintenance.
In use, yeah.
It's in use.
Yeah.
It's how do you look after something? How do you regularly refurbish? It's the energy performance of it. That's where all the money is. And if you've got information about what you've built, who's built it, you can start to manage that in use better.
Solar gains on this side of the building would be better for the building.
Which leads us to a really interesting subject that we had, topic discussion we had about whether or not manufacturers can then enter into a leasing arrangement for the components that they supply. Now, the lift industry has been doing this for a while, where they will get paid to install the lift first time round, and then they're into a service contract that lasts 20, 30, 40 years to maintain, effectively to stop people get stuck in lifts.
Yes.
But that's the fear factor why there is a service contract.
Yes.
But the output of that is you have really well maintained lifts a lot of the time, until they get to the point where you either have to take out components or just rebuild completely the moving parts. So how that fits into a steel beam, how you get into the circular economy of leasing a steel beam and say we want access to be able to buy it back, so we're not actually going to sell it to you. We're not going to sell it to you, we're going to lease it to you over its life.
And we have started looking at exactly this already. We have several projects, pilot projects going on, because, and you're absolutely right, it is only when you understand all the elements of that product, and you have, I think IoT is absolutely critical. You've got to understand how that product is performing. Also, is this product getting damaged? Has it been
service history?
Back to forklift into it, or water ingress? All of that predictive maintenance element to it. And once we understand all of that, actually, suddenly you've de-risked a little bit of that, so it becomes something that's more feasible for manufacturers to get involved with.
And and I think it is really interesting for building owners to start letting effectively manufacturers take more responsibility on their products. I mean, there are products, we love them dearly, we know everything about them, we don't want to forget them when they leave the door. We want to know, how are they performing after 30 years? Are you still happy with them? Are they, can they be reused? So we want to get more engaged with that. And I think leasing is a really interesting business model for companies like us that are looking at new ways of approaching the market.
By you being proactive in the service of assets that you've helped install and lease, by being proactive in their maintenance, effectively what you're doing is you're prolonging the life of the assets.
Absolutely.
So that means then you push out the time when essentially you need to recycle. So you get more use out of the built assets, which is why I think people want to go. When you've got finite resources, you've got a growing population, and the population is moving away from rural areas because the productivity of farming is gone, mechanicalised. They're all moving to the cities, so cities are going to come under pressure. We need to redesign cities and make them more efficient, and then we need to make them last longer.
It might be worthwhile explaining the parties that are in this focus group.
The work that we've done in terms of the R&D over a year now, coming into the second year, what we've tried to do is keep the discussions focused. And so when we have workshops, they're by invite only, effectively. And it's a formula that's been used quite a lot. It was one of the early partners that we had was the Process Innovation Forum, which helped us to map out this workshopping process, which is based on the fact that you have subject matter experts come in and they give you their views as to what's happening now and where they think the direction should go. So all the different participants that we've had are from various areas of not just construction but technology and manufacturing.
Network rail.
So on the technology side, there's what we call private blockchains, which effectively is IBM and SAP. They're interested in having their software sold to so they've got these products themselves.
But a lot of the work that we want to do is to open up the tool sets that we're doing. So we don't want to be a talking shop. We want to actually come up with tools and make them open so that people can get access. Anybody can get access to them.
Yeah.
Because it's when you do that, when you open up the tool sets, you start getting lots of people giving you their input openly, and they'll be able to just say, "Oh, I've got that. Take it. I'll change it this way," and then you end up with lots of residual benefits out of that. So there's public, there's open blockchains that we're also got into the mix, which is there's three groups. There's a Ethereum blockchain group, which they're interesting because they came up with the concepts of smart contracts,
right?
In terms of extending the use case for them. You've got Hyperledger, which is the tool sets that IBM and SAP and a lot of other technology organised use. And then there's a Helium Blockchain Association, which is looking at maybe making these tools accessible to SMEs, because SMEs may feel a bit worried about going for sign up with SAP or with IBM. So we're trying to open up the market as much as possible, increase innovation as much as possible, and then seeing what happens.
From the payment part of it, for the blockchains to give this transparency, trust and security within the payment, on the circular economy, I suppose the part that influences is small, medium enterprises that particularly wouldn't go into construction because they feel that they would be, they haven't got visibility of payments. And cash flow at the very low end is key. It's key for a small supplier. So it's a social side, is it? I suppose the payment side, it's also to bring in more SMEs, but it's also so there's the benefit at the bottom end of the chain. From the top end of the chain, from like governments and major clients, they know that the main contractor is also flowing the payments through, which answers the Egan report and the Latham report that's gone through construction. So
for the last 40, 50 years, people have been trying to change the construction industry and change the nature of the relationships and make them more equal in some respects.
Yeah.
And the construction sector is made up of SMEs. It's small and medium-sized enterprises that really drive everything. And for them to have some certainty over the fact that when they do something, they're going to get paid in a certain time frame, is a big win. So they'll be prepared to invest in the tool sets that they'll need to use digital tools more often. So that's going to be, I think, going to be a great win. If you do it this way, you will get paid in the contracted terms, and nobody will be able to say, "Oh, you haven't done this, you haven't done that," because once something's accepted, it's accepted. There's an automatic payment mechanism built in. We're not saying that we're going to introduce cryptocurrency into the whole thing. Maybe in 20, 30 years, maybe that people naturally gravitate to that. We're interested in the distributed ledger and the sharing of information.
So would that be like, would you do a payment in a token version first and then do your traditional payments and then introduce it once you've got the trust and only show percentage of payments flowing through? So you could see a percentage through. That's the point where you get the trust. You may not know values.
Yeah, that's a really interesting aspect of it. So the part of the process flow is to introduce a project bank account. And that project bank account has a number of tokens against the work that you're doing. Once a project bank account has an authorization to pay, then the person who owns the real bank account, where the real money is, it's
can then make that payment.
It's then given an instruction that you should now make the payment. There is nothing else you need to worry about. Everybody's approved. Once the project bank account says, authorise, then that smart contract process flows through to somebody who sits in front of their bank account and says, transfer money to this person.
I suppose that also makes people want to perform faster, because the quicker you install and the works are signed off, you'd get your payment at an earlier stage. If you've manufactured the steel and the steel is ready, there's no reason why that percentage of payment, once certified, could come through. I suppose that's another incentive to speed up the process, less paperwork. People probably may get frightened with this automated payment. They're worried about this, someone's going to make a payment and nobody's authorised it. But within the actual chain, it would go to the relevant parties to approve it first, but you could run it as a parallel. You could do a token one and the standard. Then if you've proven that your token payment is working, you could move that to an automated one. But it's not, we're going to switch off one another. This is going to be a step change.
The laws and commercial contracts don't stop by virtue of introducing a smart contract. You still have a right of redress if something happens.
Absolutely.
So although you pay somebody according to the terms of a contract, if you then subsequently find that there's a problem, you still have the normal kind of contractual rights to be able to go and say to that person, we all signed off on this, but we've subsequently found some inherent defects. And there is things like inherent defects insurance and stuff like that, which leads to kind of an area of other companies being able to mine data and come up with new business models. So now you know that you've got all these products out there, you know where they are. Yeah. You can start to see insurance companies will be really interested in offering things like inherent defects insurance. This one is less risk than this one's located in this area. So you can start seeing lots of different economic models. And this is applications for the data. Once people have access to data, you'd be surprised, and the more open it is, the more surprises you'll see of how many different people come up with. They'll start to Imagineer kind of new innovations around.
Well, like you're saying, you see this project as movable to different applications. So we're looking at a steel beam on an airport and tracking its start to end of life. What other applications do you feel, once you've actually proved that it does help the circular economy, it does actually drive out efficiencies in the construction industry?
Yeah, I think the where we're going to start off with is changing behaviours. So
if we can show that there's a benefit to all the project participants, that they will get paid faster, and there's going to be a lot of data that they can access, so that change of behaviours itself will start to open up other avenues of where you could take this type of technology. We've got several ideas of where we think we can deploy it. So we talked about equipment, so being able to track where equipment is, so that's a big aspect of it, and being able to say, well, what we thought it was going to be here, it's not here, it's over there. Well, how are we going to get it? So there's lots of different areas in terms of different types of projects. We're talking about construction, but in the oil and gas industry, they've got a similar sort of need to the way that the construction industry works. There are some differences, obviously, but there's some similarities. So there's lots of different to the utilities, there's mining, there's lots of. Once we start creating the tools, other people will say, we could use these in this areas as well.
Great example of that, we've just started working on very early days of a pilot project in one of our regions, and this is with a main contractor who said, well, look, we understand fully that the benefit of getting all of your data early in the process, so we can start managing, and making sure that we order at the right time, and making sure we get all of that into our planning and into our scheduling and costing, etc.
But we also understand that if we give you the right data at the right time as a construction product manufacturer, you then can start your planning and doing your admin and doing your ordering earlier, and therefore we can make this win-win.
Was there any other closing remarks you'd like to say?
No, I think just that we're obviously very excited to be part of the process. I think, as we were touching on before, there is definitely, I've been in this for 25 years in construction products, I've never seen a need at the moment and a drive at the moment to change. I think this digital transformation is coming, and exciting to be at the front end of it.
We're going to start to expose those aspects of what areas that we're looking for people to contribute to, and also make suggestions where they think stuff that we've missed. So the next aspect really is about socialising the project, so making it, expand it out, not just from the UK, but also out to Europe, the Middle East, other parts of the world.
Thank you very much for coming today and for participating. If anybody wants to talk to us about anything they've heard today, or like to contact them individually, contact them through the LinkedIn page, or the details that will come up at the end of this session. Thank you for listening to this session. If you have any questions, you can contact us through the LinkedIn, and we look forward to hearing your comments. Thank you.